Hello, and welcome back to Introduction to Astronomy. So in this segment, we want to give a general inventory of the objects that are in our solar system. So our solar system consists of one star. However, we have noticed that in our galaxy, there are other solar systems that have two stars that are in orbit around each other. And then the solar system is in orbit around that. It turns out that you could even have a solar system in between two stars. So if you have two stars that are in orbit like this around each other, you could even have a solar system in between those two stars. So when you look up into the night sky, only about 50% of the little twinkling lights that you see are one stars. And then about another 40% are going to be binary star systems. And then those binary star systems can have solar systems in orbit around them. Then you've got the 8 planets. Now you might notice that there's not 9, and that's because Pluto has been demoted. So it used to be considered an official planet, but now it's just considered to be a dwarf planet, and we'll talk more about that later. Okay, now our solar system can be divided up into 3 general areas. So the inner part of the solar system is where the terrestrial planets are going to be located at. And so we're talking about Mercury and Venus, Earth and Mars. And their size is relatively small. And you're saying to yourself, but Earth is pretty big. Yeah, but not compared to Jupiter. So compared to Jupiter, terrestrial planets are very small. They have a high density. So what do we mean by density? Okay, that's how compact an object is. It's the mass of an object divided by its volume. So that if you take a piece of paper and you crumple it up into a wad this big, then it would have a certain area and it would have a certain mass. So if you took its mass divided by its volume, that would be the density of that. Now if you take it and you crumple it up even more, well, you haven't changed the mass, but you did change the volume, so you increased its density. The composition of a terrestrial planet is going to be rock and metals. And then the number of moons is very few, because if you look at Mercury, how many moons does it have? 0. If you look at Venus, how many does it have? 0. If you look at Earth, well, it's got 1. And then if you look at Mars, it actually has 2 very small moons. Now let's compare this to Jupiter. So Jupiter is a Jovian planet, and so you got we're going to include Jupiter and Saturn and Uranus and Neptune in this category as being Jovian-sized planets. So they're located in the middle part of the solar system. They are large, so that Jupiter, for example, is about 10 times larger than what the Earth is. You could take 10 Earths and put them side by side, and that would be the diameter of Jupiter. The density is very low because they're made of gas. So they are very massive. They do have a lot of mass, but they also have a lot of volume. So that cancels it out, and so the density is low. The density of Saturn, for example, is so low that it would actually float on water. So if you had a big enough bathtub, you could take Saturn and it would actually float in the water because its density is so low. Composition, they're composed of gas, mostly hydrogen and helium. And then number of moons, a lot. So if you look at Jupiter, for example, it has something like, I think, 60 moons that are in orbit around Jupiter. And you should know why. Jupiter is big, has a lot of mass, so it must have a lot of gravity. which means it can hold on to a lot of moons. Then you have the outer part of the solar system, where this is going to be where you're going to find Pluto. And these objects are even smaller than the terrestrials. So it turns out that Pluto is about the same size as our moon. Density is going to be in between the density of a Jovian and a terrestrial, because they're composed of rock and ice. And ice is less dense than what rock is, so that gives these outer planets a less dense material. Then the composition, I said, was made of rock and ice, and they have a relatively few number of moons. We're going to find out, for example, that Pluto does have a moon that's in orbit around it. All right, so there's a description of our solar system. And then if you're interested in it, here's some more facts and figures about our solar system, if you want to look at that. Everything is scaled in comparison to the Earth. So if you say, for example, that the Earth has an orbital radius of 1 AU, then you can look at Mars, for example, and it's going to have an orbital radius of 1.52. So that's going to be how far away that Mars is going to be in comparison to the Earth. And then you can look at some of those other planets and see how far away they are from the Sun in comparison to the Earth. The next one talks about the planetary radius. So if the Earth has a radius of 1, take a look at Venus. Do you notice that Venus is almost a 1? Okay, that tells us that Venus is about the same size as the Earth. The next column talks about the mass. So if Earth has a mass of 1, then it shows how much more or less massive the other objects in our solar system are. So if you want to look at some of that, it's kind of interesting. And so in our next segment, we're going to compare the relative sizes of the objects in our solar system. So I'll be right back.